Hi, and welcome to Math Antics. In this video lesson, we're going to learn the basics of division. And if you really understand these basics, then it'll make it much easier learning how to do long division, which is the subject of our next video. Okay, so here's how basic division works then. You get a problem like this one, 9 divided by 3, which means you have a total of 9 and you want to divide it into 3 equal groups. And if you can remember that 9 is an answer to one of the multiplication facts, or that it's an answer on the multiplication table, then you can see that since 3 times 3 is 9, then 9 divided by 3 is 3. It's that simple. Well, at least it was that simple when you learned about the fact families. Now it's going to get a little bit tricky because most division problems aren't quite this easy. Like this one, 9 divided by 4. The trouble here is that 9 and 4 aren't part of a fact family. So you can't just find the answer on the multiplication table. That's because 9 is not a multiple of 4. There's no whole number that you can multiply 4 by and end up with 9. That means that 9 can't be divided equally into 4 groups without having something left over. Like if you had 9 cookies and 4 kids. Each kid could have 2 cookies, but there would be 1 left over. And in division, that leftover amount is called a remainder. So the answer to 9 divided by 4 is 2 with a remainder of 1. Alright, so it's not that hard to figure out a simple division problem when you have a picture like this. But what about when we just have numbers? To do that, we use a special division procedure. Up until now, you probably have used this division symbol the most. It works well for very simple division problems, like the ones in our fact families. But now that we're going to be doing some harder problems, we need a new division symbol. This one. This division symbol is special because it's almost like a stage that will help us solve our division problem. And there's 3 special areas of this stage where the 3 main parts or characters of our division problem will go. The first area is here under the long horizontal line on our division symbol. This is the area where we put the number that we'll be dividing up. The fancy math term for this is the dividend. Most of the time, the biggest number will go here, because we usually start with a big amount and want to divide it into smaller groups. The second area is out in front of the curved part of the division symbol. This is the area where we put the number we'll be dividing by. The math term for that is the divisor. In other words, this number will tell us how many groups we'll be dividing our big amount into. And the third area is up above the horizontal line. This is where our answer will go once we figure out what the answer is. The answer to a division problem is called the quotient. The answer tells us how many we'll end up with in each group. So whenever you have a complicated division problem to do, the first step is to rewrite your problem in this form. If you have 9 divided by 4 like this, you put the 9 down here, that's the number we're dividing up, and you put the 4 out here, that's the number we're dividing by. And you're ready to start the next step of the procedure. The next step is the most important step, because it's where you figure out the answer. And to figure out the answer, which is how many you'll end up with in each group after you divide, you have to ask yourself a really important question involving the other 2 numbers. The question is, how many 4s will it take to make 9, or almost 9? And the key to answering this question is for the number to be just right. Do you remember the story of Goldilocks and the 3 bears? How one chair was too big and one chair was too small, but the other chair was just right. Well, it's the same way with our division problem. If I choose an answer that's too big or too small, it'll cause trouble for me. Here's what I mean. Let's say that I decide that I only need 1 4 to make 9. So I'll write a 1 up here in the spot for the answer. Well, now, the next step in the procedure is to multiply that answer I put there, the 1, by the number of groups out front here, the 4. And I write the answer to that multiplication down below the number I'm dividing up, the 9. I do that so I can subtract that amount from the 9 to see how much I'm going to have left over, to see how big the remainder will be. And when I do that, I see that 9 minus 4 will give me 5. That's a pretty big remainder. In fact, the remainder is bigger than the number I'm dividing by, and that's why this answer is trouble. If the remainder is bigger than the number you're dividing by, it means that you should have picked a bigger answer, because each of the groups you're dividing up into could have gotten more than they did. Your answer was too small, and so the remainder was too big. Okay then, I guess I'd better come up with a better answer to the question, how many 4s will it take to make 9, or almost 9? This time, I think I'll pick 3. So, I put a 3 in the answer space, and then I follow the next step of the procedure like I did before. I multiply the answer I chose, 3, by the number of groups, 4, and I write the answer to that multiplication problem, 12, down below the number we're dividing up, the 9. Now I can subtract that number to see what my remainder will be. Or can I? This looks like trouble again. The answer to my multiplication is bigger than the number we're dividing up, so I can't subtract it. The remainder would be less than 0. And I can't have a remainder less than 0. That can't be right. Here's the problem. When you choose an answer that's too big, it's like trying to give too many to each group. And then you run out of things to give before the groups are equal. And if the groups aren't equal, they get all upset. Okay, so 1 was too small. It gave us too big of a remainder. And 3 is too big. There wouldn't be any remainder at all, and the groups wouldn't be equal, which causes big problems. So let's try 2. If we say that 2 4s will make 9, or almost 9, our problem looks like this. 2 goes in the answer spot, and then we do our multiplication procedure. We multiply that 2 by the 4, and we get 8. Then we write the 8 below the 9 so we can subtract it and find our remainder. 9 minus 8 equals 1. So that means our remainder is 1. Now that sounds good. It's less than our number of groups, and you can see with our cookie problem that it's exactly right. 9 cookies divided into 4 groups gives 2 cookies to each group, with 1 left over as a remainder, which we'll put right up here in our answer with an R for remainder. Perfect. And now you can see how you can do division without using pictures or cookies, but just with numbers and a procedure to follow. Let's try a couple more so you really see how it works. Let's try 23 divided by 5. We start, as always, by making sure our problem is written correctly using our new division symbol. The 23 is what we'll be dividing up. It's our dividend, so we put it under the line, and the 5 is what we're dividing by, our divisor, so it goes out front. Okay, so now we ask, how many 5s will it take to make 23 or almost 23? Well, 1 5 would be way too small. 2 5s is 10, that's also too small. 3 5s would be 15, 4 5s is 20. Oh, that sounds promising. Now 5 5s is 25, and that would be too much. So it sounds like 4 is a really good number to pick for our answer. So let's put that on the answer line. Next, we need to do the step where we multiply the answer, 4, by the number of groups, 5, and we get 20, which we'll write below the number we're dividing up, 23. Now we subtract those numbers to see what our remainder is. 23 minus 20 is 3. Well, that's good. 3 is less than our number of groups, so it's a reasonable remainder. So our answer to 23 divided by 5 is 4 with a remainder of 3. Let's do one more before you try working some out on your own, okay? Let's do 57 divided by 6. First, we set up our problem, and then we ask the question, how many 6s do we need to make 57 or almost 57? Well, this one's a little more tricky, so I think I might use a multiplication table to help me out. The nice thing about a multiplication table is that it shows me all the multiples of a number. For example, since I want to know how many 6s I need, I can look on this row of the chart and see all the multiples of 6. Here they are: 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. We need the multiple that's 57, or almost 57. And since 57 is not on the list, it looks like 54 is the next closest thing, without being too big like 60. And to get 54, we need to have 9 6s, so we'll choose 9 as our answer. Next, we multiply 9 by 6, which we already know will give us 54 because that's what our multiplication table showed us. Now we need to subtract 54 from 57. That gives us a remainder of 3. Again, that's good because that's less than our divisor. So 57 divided by 6 equals 9 with a remainder of 3. All right, that's all for this lesson. And if you're new to division, that's plenty to get you started. It's really important to master these basic division problems that just involve one step that leaves you with the remainder. In the next video, we're going to learn how to take this basic procedure we've learned and repeat it multiple times in a process called long division. Hi, welcome to Math Antics. In this lesson, we're going to learn about long division. If you haven't already watched our video about basic division, then be sure to go back and watch that first. It'll make learning long division a lot easier. Long division is just a way of breaking up a bigger division problem into a series of short division steps like the ones that we did in the basic division video. The nice thing about long division is that once you know the procedure, you can divide up all kinds of numbers, even if they're really big. The key to long division is to think about our division problem digit by digit. If our dividend, the number we're dividing up, has a lot of digits, then that means that there'll be a lot of division steps to do. When we learned basic one-step division, all of the dividends were small enough that we could just use the multiplication table to help us find the answer. But what if we have a division problem like this, 936 divided by 4? 936 is definitely not on our multiplication table. In fact, there's not anything even close to 936. So what do? Well, instead of trying to divide the entire 936 by 4 all at once, let's break this problem up into smaller steps by just trying to divide each digit by 4, one digit at a time, digit by digit. Do you remember how with multi-digit multiplication and addition, we always start with the smallest digit, the ones place digit, and we work from right to left? Well, division is backwards. We still go digit by digit, but the other way. We start by trying to divide up the digit in the biggest number place first, and we work our way from left to right. So the first step in this problem is to divide the first digit of our dividend by 4. We'll just ignore the other digits for now. And that makes it look like we have the division problem 9 divided by 4. Great, that's easy. It's just a basic division problem like in the last video. So we ask, how many 4s will it take to make 9 or almost 9? Well, 2 4s would be 8, and that's almost 9. So just like before, we put the 2 in our answer spot on top of the line. But wait a minute, there's a lot of room up there. Where exactly do we put it? Well, the answer digit should always go directly above the digit we're dividing. Since we're dividing the digit 9, our 2 should go right above the 9. Okay, now we multiply. 2 times 4 is 8, and the 8 goes below the 9 so that we can subtract to get our remainder. 9 minus 8 is 1, so our remainder is 1. Now at this point, in our basic one-step division problems, we would rewrite our remainder up in our answer with a little r next to it. But we aren't going to do that yet because this is long division, and we still have more digits to divide, the ones we've been ignoring. Since we're going digit by digit, let's stop ignoring the next digit in our dividend, the 3. Now you might think that our next division step is to divide that 3 by the 4, but it's not quite that simple. We had a remainder from our last division step, and we can't just forget about that. We need to combine that remainder with our next digit and divide them both together. We do that by bringing down a copy of the next digit, the 3, and put it right beside the remainder, which is 1. When we do that, it looks like our remainder is 13. It's kind of like our remainder is teaming up with the next digit over. And if you think about it, that makes sense, because the digits that we were ignoring during our first division step really are part of the remainder because we still need to divide them. Okay, so bringing down that next digit makes our remainder bigger. And that's good, because before, the remainder was so small that 4 couldn't divide into it. But now it's 13, and 4 will divide into 13. So we ask, how many 4s will it take to make 13? Well, 3 4s would be 12, and that's really close without being too big. So let's put 3 in our answer line. Yep, it goes right over the 3 because that's the next digit we were dividing in this digit by digit process. And then 3 times 4 is 12, which we put right below the 13 so that we can subtract to get the next remainder, which will also be 1. See how we're just repeating the basic division procedure? But we're going further down the screen as we do. All right, now that we have a new remainder, it's time for our next division step. Let's stop ignoring the last digit in the dividend, the 6, and bring down a copy of it to team up with our new remainder. Together, they form a remainder of 16. Aha! That's good because it's going to be easy to divide 4 into 16, because 16 is a multiple of 4. It takes exactly 4 4s to make 16. So we put a 4 in the last place of our answer line, and then we write the 16 below our new remainder. Now, if we subtract 16 from 16, we see that our last remainder will be 0, which means there's no remainder left. That's great! We solved the whole division problem digit by digit by breaking it up into 3 basic division steps. And now we know that 936 divided by 4 equals 234. And we also know why they call it long division. In fact, that was so long I think I need a coffee break. Oh, man, that was some long division. Whew, let's see. Okay, so that problem had a 3-digit dividend, and it also had 3 division steps. But the number of steps isn't always the same as the number of digits we have. And that's because the number of steps also depends on how big our divisor is. To see what I mean, let's work 2 division problems side by side. These both look like the basic one-step division problems that you did in the last video, don't they? But as you'll see, one of them is actually a 2-step problem. Let's start with the first problem, 72 divided by 8. We just ask how many 8s does it take to make 72, or almost 72. Well, that's easy. On our multiplication table, you can see that 72 is a multiple of 8. 8 times 9 equals 72. So we put 9 in our answer line, and we write 72 below, and we see that we have no remainder. Now let's try the next problem, 72 divided by 3. If we ask how many 3s will it take to make 72, or almost 72, we can see that the answer is not on our multiplication chart. The biggest multiple of 3 listed there is 30, which isn't even close. The reason is that this should really be a 2-step problem. Let's try using the new digit by digit method we just learned. Instead of asking how many 3s make 72, let's just focus on the first digit and ask how many 3s does it take to make 7. Ah, that's easy. 2 3s would give us 6, which is very close. So let's put a 2 in the answer line right above the 7. Then we multiply 2 times 3, and that makes 6, and we subtract 6 from 7 to get a remainder of 1. Now for the second step. We bring down a copy of the next digit, the 2, and we combine it with the 1 to get a new remainder of 12. Then we ask, how many 3's does it take to make 12? And the answer to that is exactly 4. So we write a 4 in the answer line, and 3 times 4 equals 12. 12 minus 12 equals 0, so we have no remainder. We're done. 72 divided by 3 is 24. Now here's the interesting thing about these examples. The first problem could have been a two-step problem also. If we had taken it digit by digit, we would have first asked how many 8's does it take to make 7, or almost 7. But the answer would have been 0, since 8 is too big to divide into 7. We would have put 0 in our answer line, and the remainder would have just been 7. So basically, we just skip that step. And that'll happen with digit by digit division sometimes. If the number's too small to divide into, you just put a 0 in the answer line, and you move on to the next digit. Okay, now that you know the procedure for long division, are you ready to see a really long problem? Good, I thought so. Let's divide 315,270 by 5. Now don't worry, it's really not that hard if you just go digit by digit. I'm going to work the problem pretty fast, so don't worry if you don't follow all the math. Just focus on the repeating division process as we go along. Are you ready? The first digit is 3. How many times will 5 divide into 3? 0. 5's too big, so let's just skip that step and combine our first digit with our next digit. So how many times does 5 divide into 31? 6. 6 times 5 is 30, and 31 minus 30 gives us a remainder of 1. Now on to the third digit. We bring a copy of it down to join with the remainder, and we ask how many times will 5 divide into 15? 3. 3 times 5 is 15, and 15 minus 15 is 0. On to the next digit. Now even though our previous remainder was 0, we still bring down a copy of the next digit. Now we ask how many times will 5 divide into 2? 0. 5's too big, so we need to move on to the next digit and bring a copy of it down also. There, that's better. Now we ask, how many times will 5 divide into 27? 5. 5 times 5 is 25, and 27 minus 25 gives us a remainder of 2. Now for that last digit, which is a 0. And you might wonder, why do we even have to bring a copy of a 0 down? Isn't that nothing? But the 0 is an important placeholder, and when we bring a copy of it down, it changes our remainder of 2 into a remainder of 20. Now that's a big difference. Now we ask, how many times will 5 divide into 20? 4. 4 times 5 is 20, and 20 minus 20 is 0. Yes, we're done. There's no more digits to divide, and you can see that our final answer is 63,054. All right, that's a procedure for long division. As you can see, it's kind of complicated, so don't get discouraged if you're confused at first. Like almost everything, it just takes practice. So, as you get ready to practice some long division problems on your own, here's a few tips that'll help you out. First, if you haven't already done it, memorizing your multiplication table will really help with division. Second, when you're working problems, it's really important to write neatly and stay organized. If your writing's messy, it might be hard to keep your columns lined up, and that could lead to mistakes. And if that's the case, try using graph paper to help keep things lined up. Third, start with some smaller 2 or 3 digit dividends, so you only have a few division steps to do. Then work up to the longer problems. And last of all, after each practice problem you do, check your answer with a calculator. That will let you know right away if you've made any mistakes so you can correct them, and most importantly, learn from them. And it will give you practice with a calculator, which is also important. All right, that's all for this lesson. Thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.